Innospace, founded in 2017 and headquartered in South Korea, specializes in the aerospace and defense manufacturing sector, with extensive expertise in hybrid rocket technology. The company has already flown several low-cost sounding rockets and is now venturing into the small satellite launcher market with larger, more powerful orbital rockets. We'll explore the details and specifications of these rockets later, but first let's trace the key milestones this South Korean firm has achieved on its journey to potentially launching Asia's first successful private commercial orbital rocket. Innospace aims to deliver easy, fast and affordable access to space in the costly smallsat launcher market, which they describe as gridlocked. They prioritize low latency launches, striving for quicker and more frequent launches than the industry currently offers. In 2018, just a year after its founding, Innospace established Plant 1, supported by funding from the South Korean government, which recognized the company as a growth potential startup. The following year, 2019, saw the company set up Plant 2 and complete a seeding round to secure further investment. By 2020, Innospace had developed a 15 kN thrust engine and expanded its global presence by opening an office in Brazil. In 2021, the company secured an operator's license from the Alcantara Space Center in Brazil and successfully developed a 50 kN thrust engine. That same year, they built Plant 3, attracted more private investment, and conducted a successful hot-fire test of their smaller 15 kN engine. The year 2022 marked further progress as Innospace landed its first payload contract with the Brazilian Air Force and established an office in Europe. Later that year, they signed additional payload contracts with Brazil, strengthening their international partnerships. In 2023, Innospace achieved a significant milestone by successfully test launching their Hanbit TLV rocket from the Alcantara Space Center in Brazil. In August of that year, they signed a multi-launch agreement with the Equatorial Launch Australia, with launches to be carried out from the Arnhem Space Center in Australia. This is a 5-year contract ending in December 2028, with first launches tentatively scheduled for 2025. Arnhem has designated Innospace as their first resident launcher, which means they are classed as a long-term client of the launch site. Throughout 2024, Innospace focused on developing and testing their engines, while also expanding their global footprint by setting up offices in the United Arab Emirates. At the 75th International Astronomical Congress in Milan, Italy, Innospace actively engaged with over 60 satellite companies and partner institutions worldwide, scheduling business meetings to explore potential satellite launch service agreements and partnerships. The company also promoted its commercial launch plans for the Hanbit family to attract new customers. Innospace targets launching the Hanbit Nano with a 90 kg, that's 200 pound payload capacity, in the first half of 2025, followed by the Hanbit Micro, capable of carrying 170 kilos or 375 pounds in the second half of 2025. Looking further ahead, the Hanbit Mini boasts 1,300 kilos or 2,866 pounds payload capacity and a first stage powered by a cluster of 9 25-ton hybrid engines. It's scheduled for the second half of 2026. Innospace went public in July 2024, listing on the South Korea's KOSDAQ market. The company plans to channel the funds raised through the IPO into expanding its production capacity, advancing research and development for lightweight and reusable space launch vehicles, and attracting top talent. So-Jung Kim, CEO and founder of Innospace, commented on the KOSDAQ listing. By successfully entering the KOSDAQ market today, we have set a new milestone as Korea's first listed private space launch vehicle company. Innospace is committed to accelerating the development of our launch vehicles to achieve early market entry and provide stable, tailored launch services, ultimately growing into a competitive player in the global space market, unquote. Innospace adopts methane engine for the upper stage of launch vehicles. Innospace initially planned to use a hybrid engine on the upper stage. This is retained as an option, but now customers can choose the new methane engine currently under development. Innospace promotes its hybrid engines as safe and cost-effective, relying on paraffin. It's essentially a large stick of candle wax as fuel. This eliminates the need for complex pumps, valves, or intricate plumbing, reducing costs and minimizing explosion risks. So why introduce a methane engine? The methane engine excels at precisely and efficiently deploying multiple satellites into distinct orbits during a single mission. Its ability to reignite multiple times and provide accurate reaction control enables the engine to ignite and shut down repeatedly in space, positioning each satellite into its intended orbit. This feature is important for customers who are increasingly wanting to deploy constellations of satellites into orbit. Sojung Kim, CEO of Innospace, commented, "With the adoption of the methane engine, Innospace expects to be able to offer either hybrid or methane engines, depending on the specific requirements of each launch mission, allowing us to provide customers with more flexible and efficient launch systems." Innospace Orbital Rockets. Innospace offers a range of rockets with different upper stage engines. First, we cover the Hanbit Micro and Hanbit Mini, set for future release, followed by the Hanbit Nano, scheduled for its first launch later this year. Hanbit Micro. The Hanbit Micro, a two-stage launch vehicle with an additional kick stage, carries a 170 kg payload to a 500 km sun-synchronous orbit. Its first stage is powered by a 25-ton thrust hybrid engine, while the second stage uses two 3-ton thrust engines. The kick stage enables precise placement into the customer's intended orbit. Hanbit Mini. The Hanbit Mini, a 3-stage launch vehicle, delivers 1,300 kg payload to a 500 km sun-synchronous orbit. Its first stage features 9 25-ton hybrid engines, the second stage uses a single 25-ton hybrid engine, and the third stage uses two 3-ton methane engines. By combining hybrid and 3D printed methane engine technologies, the Hanbit Mini offers safety, cost-effectiveness, and high thrust, enabling rapid, low-cost launch services. Hanbit Nano. The Hanbit Nano, a 2-stage launch vehicle, transports a 90 kg payload to a 500 km sun-synchronous orbit. Its first stage relies on a 25-ton thrust hybrid engine, while the second stage uses a 3-ton thrust engine. Depending on mission requirements, the second stage can use either a hybrid engine or a methane engine. From an ex-post, Innospace states, "Innospace's Hanbit Nano, our first orbital launcher, will support customers in achieving their goals by providing reliable launch services with precision orbital deployment." Unquote. The development and testing campaign for the Hanbit Nano's upper stage methane engine, Lima 3, is moving ahead quickly, with static fire tests of the thrust chamber assembly conducted under various operating conditions and adjustments. Their team is working towards delivering a reliable and highly efficient second stage engine with many tests underway. Innospace has completed the fairing separation test for the Hanbit Nano's 2.6 meter tall, 1.4 meter diameter fairing. This fairing, designed to protect the satellite during launch, passed the test, confirming the separation device's responsiveness and the spring assembly's functionality. High-speed footage helped the company quantify the separation speed and verify the mechanism's accuracy. Launch sites. Innospace will be launching from 3 spaceports. Alcantara Space Center in Brazil. This spaceport is only 2 degrees south of the equator, making it ideal for geostationary orbits. Arnhem Space Center, Australia. This spaceport is 12 degrees south of the equator and will be used for low to mid-orbital inclination missions. Andøya Spaceport, Norway. Andøya, which hosts ISAR Aerospace, will also be used by Innospace in the future. This spaceport is suitable for sun-synchronous and polar orbits. Preparations for first orbital flight. Innospace successfully completed the Launchpad Vehicle Interface Integrated System test for its Hanbit Nano launch vehicle at Samwoo Eco's facility in Gwangyang, South Korea. The company tested the new portable launch pad it developed, verifying critical systems including mechanical and electrical interfaces, the transporter erector launcher, umbilical detachment, propellant supply and hold-down mechanism separation. The test confirmed the operational reliability of both the launch pad and the Hanbit Nano qualification model, which matches the specifications of the flight model, that is, it's 21.8 meters tall and 1.4 meters in diameter, and is set for a July launch. The launch pad was shipped to Brazil's Alcantara Space Center in April for installation and final checks in May. Okay, that's a wrap. Thanks for watching. A quick note, Space News Live is on Saturday evening or Sunday morning, depending where you watch from. I recap the videos I posted this week, answer questions, respond to comments and chat messages, cover any missed news and preview upcoming content. I'd love for you to join if you can. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.